Hey guys, welcome back to the channel. So this is a part 5 of building a 3-in-1 CNC, and it's been a long time since I started the work onto this machine, but finally it's glad to see that the machine comes to the finished state. It's not completely finished yet, but the good thing is that it start to do the job, and I can say that the machine is finally alive. So without further any delay, let's build it. So starting off, this build is done from this pile of wire, and to manage all the wires I'm going to use the vertical member of the machine. Onto the top I am going to drill down some holes so that I am able to feed the wire from those pillars for a better cable management. The final drill hole onto the top is around 18 mm. I also remove the carriage and the cover plate so that I am able to access the cabin underneath the carriage. To feed the wire from those pillars, I need to drill down some holes into the bracket also so that the wire remain hidden inside the whole structure. This is the Maven cable which I'm going to use to connect the board to the extruder heater. All of the wires which are going to be inserted come from the bottom to the top and then reach up to the bottom so that it would be easy for the head to move around. Then just from eyeballing, I measure the length of the cable and cut it to the required length. Once all the wire has been fed out in the entire frame, I start the naming process of the wire so that it would be easy for me to recognize the wire during the final connection. Then I start the work onto the front panel, and to exhaust the hot air from the chamber, I decided to use this AC fan. I made the layout on the front panel and then made a cutout with the help of angle grinder and complete it with the help of jigsaw. For the protection, I am using this fan grill. I place it onto the panel and make it square and mark the whole location for much better control onto the machine. I made some holes to fit the button. I did this off camera, but it's done all with drilling and some filing. For the mains on and off, I am using 30 amp rocker switch. For controlling 3 different equipments, I am using this round rocker switch. These are the little thimbles which comes in handy to connect the wire with the switches like this, and it would be easy if you want to disassemble any component from the rig. To make the front panel insulated, I am going to use this electrical tape and cover the panel. But before that, I made a space for the graphic display to mount onto the panel, but unfortunately I am not going to use this display because I changed the RAM board with the Duet Wi-Fi board. But I think I can use these holes and slot for mounting the new LCD display. Once the insulation is done, I start the work onto the wiring, and as I show earlier, I am using thimbles connector onto these switches, so I crimp all the wires to the connector and connect them to the switches. This method is much easier as compared to soldering each wire individually. Once the wire connection has been completed, I connect it to the power supply and the mains. During this time, I was planning to put a PC inside this case, but in the end I changed the mind because Duet Wi-Fi not needed a PC permanently connected to it. That's why I skipped that step. After that, I assembled everything and made my first test run, and this is the first time when I found that the machine is not able to run properly, and during the printing time it start to skip the steps. And to figure out this problem, it took me around 2 months of research, about which I discussed in my previous video. video. So here I have a Duet Wi-Fi board with touch LCD display. Along with that, I also decided to change the NEMA 23 motor with a bigger one having 189 Newton centimeter torque, and because of EMF problem I also changed the ball screw with 5M timing belt to provide a drive to my CNC. Along with that, I am using a 5M timing pulley having 28 teeth onto it, and because of this configuration it provides me a lead of around 150 millimeter in a single rotation. For my build I am using two different kinds of pulley, one having a bearing installed in it and other having a hole of 6.35 millimeter which need to be connected to the shaft of the stepper motor. Since I changed the drive mechanism, that's why I need to replace the mounting bracket, and for that I am using a 3x3 angle bracket having a 54 millimeter hole drill inside it and having a slot onto the other side so that I am able to slide the position for a better accuracy. The bracket onto the opposite end is completely different from the motor mounting bracket. Onto the one side I have a slot for fine tuning the height of the pulley, and for the other side I have a half-inch square bar piece with M8 threaded hole in it, along with the two mounting holes onto the either side, and onto the angle there are threaded holes in which I screw down it to its place. And this is the third part onto which timing pulley has been installed, it having 3 holes, one for the pulley mount and remaining 2 are for holding the pulley to its position. The pulley have a bearing fitted inside it and a M8 Allen bolt locked it to its place, and when grub screw screwed in it, it pushes the pulley and tightens the belt, and if you unscrew it, it loses the belt. And from underneath there are 2 screws which help to hold that pulley to the desired position, and here you can see that how this assembly slides in that slot, and this small movement inside this bracket helps to tighten the belt. And now I'm going to install them onto the machine, so the holes I drilled in the bracket are at the same distance like the old bracket, and now I have no need to drill any additional holes for the new mounting bracket. And now holes onto the new bracket can be easily matched with the holes drilled onto the frame. The height is kept in such a way that the bed easily glides over the pulley without interrupting the motion. The adjustable pulley is going to be installed onto the opposite end, so here I need to drill down the additional holes to mount the bracket so that I am able to join this to the pulley together. So I made a marking onto the frame, drill down the holes and tap them with M5 thread tap. Along with that, for easy accessibility of grub screw, I need to make a notch so that it would be easy for me to reach to the head of the grub screw for tightening the belt. Here I need to grind down the top of the bolt to make a clearance for the carriage. To mount the bracket onto the y-axis, I decided not to drill any extra holes onto the frame, and instead of that I decided to use the previously drilled holes which are already been used by the linear bearings, and the only thing I need to do is to replace the Allen bolt with the larger one. So the tightening pulley bracket of x-axis is slightly different than what I constructed for y-axis, but there was not a huge difference in the construction perspective. In this situation, for the belt tightening, the screw needs to push the pulley to the sideways as compared to y-axis, in which the grub screw pushes the pulley to the back side. Once the pulley has been installed, I start the work onto the belt and cut down the belt up to the shortest length so that when grub screw pushes the pulley, it tightens the belt. Clamp the belt to the y-axis, and for the effective joint I use the leftover piece from the same belt and overlap this piece to the open ends so that it matches the teeth and clamp them tightly. By doing this, there is no way that the belt become loose after a couple of uses. To make a clamp, I am using 10mm plate piece, cut it into 2 equal sections. The one piece is going to be bolted down with the carriage, while the second piece is going to hold the belt against the previous piece. Now both the piece has been prepared and it's time to install them onto the carriage. I mark the hole location onto the clamp in such a way that I don't need to drill any additional holes onto the carriage. Once the dry work done, I made a test print and everything started to run as it needed to be. From thereafter I made a couple of prints like spool holder, but I found that the bed is not level perfectly, and to counter that problem I decided to put a BL touch into the machine. I made a setup so that I can attach it to the side of the extruder, and the height is kept in such a way that the BL touch is 1 millimeter higher than the extruder nozzle. To install it, I am temporarily attaching it with the CA glue. The wiring of BL touch is pretty simple. There are two groups of wire, one having a 2 wires and other having 3 wires. The 2 wires needed to be connected to the probe location as shown in the image, and the remaining 3 wires need to be connected to the expansion connector, and all the points which are used for expansion heater can be used to provide signal to the servo in BL touch. After setting up this sensor, I made a print and the result is extremely promising. I printed out end caps, some fan bracket to keep the motor cool during the printing. Then a U bracket helped to keep the fan bracket to its place. Along with that, I print couple of more spool collar and load the filament onto the machine. I also printed a bracket onto which those spools are needed to be mounted, having a bearing installed in them for a easy rotation. So here I have all the material which I'm going to use to build my heated bed. So the bottom base is going to be a piece of MDF board which is 12 millimeter in thickness, and over the top I am going to apply a Kapton tape. Thereafter I am going to connect the heat plate together with the Mavin cable. I am going to build 2 separate rows of heat plates so that I am able to control them separately. I also cut down some strip of 6 millimeter thick MDF to create a recessed area for the heat plate, and with this setup, when I place a 4 millimeter glass over the top, the whole setup became completely flush. To control each row separately, I am going to use these 30 amp MOSFET. Top is covered by another sheet of MDF which is going to be used for the CNC routing purpose. When I have to use the CNC portion, I just screw this board to the bed and start the machining. Then I glue down the strips along the 2 sides of the heated bed. For effective cable routing, I made a layout onto the MDF and carve a channel with the help of palm router so that wire can be managed without interfering the plate. Then I made some marking onto the aluminium plate and drilled couple of holes and threaded them with M5 thread tap. Once the work has been finished onto the aluminum plate, I transfer those holes onto the MDF bed, drill down the holes onto the bed and made the screw completely flush to the surface. Once this work is finished, I insert the glass and glue the remaining strips to the MDF bed. Before applying the Kapton tape, I clean the bed with the help of acetone. After that, I applied 2 layers of Kapton tape over the bed. I also made a connection of the heat plate in series. So during the cable management of the heated bed, I faced some problem in laying the plates completely flush, and because of that I need to carve new route for the cable, and this thing solved my problem completely. Then I install the carriage onto the y-axis and over the top screw down the MDF bed to its place by matching the holes. So you can see how I attach those heat plate together in series, and the only reason for doing that is because if I needed to make a small print, then in that case I don't have to turn on the entire bed. Although I plan to control each bed separately in the future, that will make it much more efficient, but for now this is the setup. The thermistor is going to be attached only on one plate, and the temperature onto the remaining plate is going to be adjusted by this thermistor only. The connection with the MOSFET is pretty simple, and you need to do is to connect the positive of the heated bed to the positive of the MOSFET and the negative to the negative of the MOSFET. On the other side, the DC negative needs to be connected with the ground of power supply, and the positive connects to the positive of the power supply, which is either 12 volt or 24 volt. In my case it's 12 volt, and these two wires are going to be connected to the heated bed point onto the main board, so that the MOSFET can read the signal coming from the Duet board to turn itself on and off. To provide power to the bed, I am using two separate power supply of 40 amps. For the better cable management, I am using these marking lugs and going to name each wire separately. Here you can see that there are some alphabets written onto each lug, and with these lugs I am able to give name to each wire, so that in future if anything goes wrong, then it would be easy for me to identify the wire. Along with that, I am also going to remove the motherboard which I installed earlier, so that I am able to make some space for the power supply inside that chamber. The diameter of these lugs is around 2.5 millimeter, which is more than sufficient I needed. And now I'm going to disassemble every connection and give them names. Along with that, I also going to mount the power supply in vertical position, so that they will acquire less space and seems to be look pretty and organized. And here you can see how everything looks after the cable management has been completed. I shift the board position to the left side so that it will not come in the path of power supply area. Now I made first time some test print with the ABS. It's extremely difficult to work with ABS because it warps a lot, but this print goes okay and didn't warp that much. Then I decided to see how much time the bed take for a complete heat up to 100 degrees Celsius, and it's not a huge deal for the bed to reach up to that temperature, but during the cooling process I heard some sounds of clicking, but I didn't pay much attention to it. And in the evening when I come for a print, I found that the glass shattered from multiple sides in irregular manner, so I needed to replace that glass with 6 millimeter of glass, and this glass is also tempered so that this incident will never happen again. With the new glass I made a print of LCD case, and the filament sticks with the bed quite effectively, and the print quality also came up pretty good. Once the print has been completed, I am going to mount them onto the front panel. I also made some prints for the MOSFET. Since I installed a slightly thicker glass, that's why I needed to cut down some strip and glued it around the periphery of that glass to make it completely flush to the surface. Now the 3D printed part has been completed and I can focus onto the CNC portion. First I made the connection of the spindle with the power supply and seal the joint with shrink tube. After that I placed that MDF board over the heated bed. So to activate the CNC mode, I need to go to the macros and click onto the CNC program. Now the CNC program has been loaded. In the CNC area I am using a limit switch for homing the Z axis, and I slightly modify the design for the limit switch. With this limit switch I made a touch plate, and for that I triggered the limit switch manually with the spring clamp and cut the signal wire of the limit switch and connected each end with a gator clip. And when these two clips comes in contact, the board reads the signal and stop the Z axis. And here you can see in the video that when I touches these clips together, there is a light blink onto the board which indicates that Z axis limit switch has been triggered. Now I'm going to show you this homing cycle with the touch plate I built. Here I connected one clip to the plate which is lying onto the bed, and the second clip is connected to the roughing bit onto the spindle. And when I run the homing cycle, you can see that the machine stops and You can use whatever thickness you want for the touch plate, and to eliminate that thickness you can provide an offset into the Z homing file in the system folder. You can see that the bit is barely kisses the steel plate and there is no problem in removing the plate. For sacrificial board I am using my old board which have been recovered from the previous CNC, and I cut it to the required length which I needed for this one. Then I screw down the sacrificial board and the MDF board to the main bed. So there is a distance between the printer extruder and the spindle, so to minimize that gap I printed out some extension arms which are going to mount it onto the linear bearing underneath the carriage and helps to stop the y-axis carriage to the required distance. So every time when I'm going to change the machine to the CNC mode, I also need to replace this extension arm with the shorter one. I also decided to change the laser position and shorten the plate onto which extruder and laser are mounted together. I shifted the extruder position slightly backward up to the position of laser and made 3D printed case for the laser so that I can mount it onto the extruder whenever I need this. These two assemblies can be easily fitted like this. Along with that, I also printed a case for the Duet. The old one is printed with ABS and warped a lot, and there are some cracks also. The new one is printed with PLA and it's completely straight. Then I made marking onto the laser mount and attached the laser. I now attach the BL touch to this and install it onto the plate where extruder is already mounted. Now after installing the laser, it's ready to cut. To set up the Duet Wi-Fi board, I built another video. You can check that. The link is in the description, or you can click on the card on the upper right corner. Now I'm going to show you how all of these things actually works. So this video is not going to be the finale because I am planning to build a separate video for that to show you all the feature of this 3-in-1 machine with couple of projects in that showcasing the functionality of this machine, and also going to do some touch up over this build to match it exactly how I wanted. So till then, goodbye, have a great day.